But for those who don't know me, Jim Glidewell, I'm one of the co-leads of our enterprise HPC service. And sorry about this title. It sounded like a really good title at the time, but you know, I put it in and I said, seems good. And then came back a month or two later and said, dealing with. That kind of, it's kind of, you can almost hear the sigh and involved in it. And, you know, I think you have to really read it with, since we're here in the shadow of Disney and Eeyore sort of voice. But I still think that there's something really enjoyable about dealing with changes and as a system administrator, as a system manager, as a PBS administrator, trying to solve problems as they arise going forward. And one of the things you obviously want to do is try and get ahead of problems rather than be completely reactive. And so I'm going to talk a little bit about some changes we're seeing, and maybe you folks are seeing them too. So what does our site look like? Again, we're the enterprise HPC service. We're not the only HPC service within Boeing by any means. There are other services that serve specific projects and some other areas, but we have a charter to basically take on all comers. So we have multiple locations, multiple clusters in each location. HP gear, Mellanox, InfiniBand interconnect, Panasys storage are kind of the building blocks of our service. And we've been a long time PBS Pro user, reaching back to about 2000 when we ran it on Cray and SGI systems. So what's happening at our site? As Tolstoy said, every happy family is the same, every unhappy family is a little different. HPC is kind of each HPC site is kind of its own unhappy family, I guess. So everybody's got their own challenges. I think there's some commonality, but again, this is the stuff that we're seeing at our site. So one of the things that's kind of happened at Boeing is we've moved from being kind of a rarefied and specialized service that served a very small community to something that's really kind of akin to an internal engineering cloud. We're seeing lots and lots of people come to us and look for solutions to applications that have just simply outgrown their desktops. And so, of course, with that comes the continuing challenge of people who have never typed in anything on a command line. And so because of this, we're looking at things like Compute Manager and other products in that space to try and figure out how we can best address those folks' needs. And again, another thing that's causing this influx of new users is we have broadened our general charter. We used to be pretty much focused on the commercial aircraft side of the house. Now we're being expected to address the needs of all the other divisions. Those guys come with their own applications and their own way of doing business. And so it's a significant amount of change. So, and so the next bullet, the changing workload, I think I heard this last year at the user group that other people were seeing a shift towards smaller jobs. Certainly that's kind of hit us with like a ton of bricks. And so we've had some challenges there. I want to kind of share with you how we work those challenges and, you know, and also solicit from anyone their suggestions on how they've dealt with large quantities of jobs. I know that that's a common thing in some other spaces that PBS serves. So this is what our job count looks like. For a lot of years we were a cluster site and 1 million jobs a year. That was what we did, and that was what we always did. And then a couple years ago things changed, and I expect that number to keep going up. A lot of this is JobaRace. And JobaRace are very convenient for users, but they are not without system impact. They're still independent jobs. And so anyway, things are going up. So, you know, Altair's really done a lot of work on trying to address this. You know, being able to queue sub rates, spawn rates, things like that. And The good news is they've succeeded. The bad news is we have uncovered issues along the way. Timing windows that weren't obvious become obvious when you increase some rate by a factor of 10. A problem that we certainly have locally is that our Prologue and Epilogue really were not written and designed to deal with high rates of job turnover. We were still kind of in our cray mindset where we were going to run a couple hundred jobs a day. Now we're running, thousands to tens of thousands, and so we're seeing that the Prologue and Epilogue are becoming bottlenecks, and we're looking at ways we can address those, including mom hooks as an option. But so one of the things we found is that this sort of high job turnover, and again, this kind of comes in waves. It isn't a continuous thing. Instead, it'll be somebody's got a critical project and they're already really, really in love with JobaRace. And so, so we'll have these waves of things, and they were causing some performance problems. So I think that really dealing with large numbers of jobs takes, everybody to kind of pitch in a little bit, Altair, us, and while I like to let users do what they want to do, I still think that there are times that they can help us serve them better. So, so a denial of service attack, what could that be? Well, it could be something that looks kind of like that. This is a definitely do not try at home, at least not with quite that many zeros after it. This is a job array, a million elements, just saying hello world. That will cause PBS to get very energetic in terms of trying to start these jobs and trying to finish them. And because the bulk, if not all, of the PBS server is single-threaded, this will block all kinds of things. You'll block the ability to QDEL this job, among other things. But so again, if you're really tempted, maybe take away half of those zeros and run it on a test system, and you'll see that it is a kind of a toxic job. So, and it's not just an artificial job that I made up. We actually saw this. So our Southwest data center, we were getting a lot of user complaints. We're getting user complaints from people like me and the rest of the staff that couldn't actually look at anything because we were finding that we were getting so swamped by relatively small job arrays that we weren't able to actually get any status output out of the server. When we finally could get QStat to work, we saw that there were these job arrays, and the subjobs are not really, particularly, that's not an unreasonable sort of job array element, but it was enough to cause issues for us. That and the fact that they love to generate a bunch of files which happen to be on the same file system that PBS was using for PBS Home. So, surprise, surprise, you slow down the rate of jobs and things get better. But how do we do that really without, and still let these users get their work done? And so we, took some emergency responses on clamping down the number of jobs, but that wasn't going to hold because those guys were already missing deadlines. We tried a sleep hook, which was a recommendation from Altair, and it had unfortunate side effects, I guess. So we really wanted to, we said, let's do a hook to limit job initiation. So that's what we did. So one of the things that's interesting here is just to look at the stuff that happens in a PBS job as you run it. There's at least one item here. The Prologue from Bright is something that isn't common to PBS itself, but that's how we hook Bright Cluster Manager into our environment. It has its own Prologue, and then we call our local Prologue. But really, there's all these steps. But the thing to note is, my magic pink didn't show up. Okay, but the main thing to note is this one line is the only thing where you're actually doing useful work on behalf of the user. And if that becomes vanishingly small relative to everything else, obviously you got an awful lot of overhead. So what did we do? We created a rate limit hook. I actually had kind of the beginnings of this concept in a previous hook I did for License Manager, but this one was specific to this. It is a pure hook. It doesn't require requires a single file outside itself. But the idea is that we would rate limit both the number of jobs that we initiated by PBS and the number of jobs for any one user associated. And so we had, these are kind of arbitrary numbers we picked, 60-second interval, 10 jobs per user, 80 jobs overall. That seemed to be a happy sort of numbers that we thought we could work with. Again, obviously always adjustable. And any job that exceeds the limit gets put in a wait state, kind of the standard hook strategy for a run job hook. So here we have the hook itself. Here we have the side file, which contains a list of who's submitted jobs and when those jobs, who's had jobs initiate and what the timestamp is associated with that. Read the status file, look at stuff that's outside, throw away stuff that's outside the interval. If in fact a job passes, then we add that job to the list and accept it. Otherwise, modify the job to run again in the future and reject it. This actually has worked out pretty well for us. It certainly fixed the problem that we were trying to address directly, which was we had this unresponsive PBS server, which was making both Q-subs and Q-stats be very erratic in terms of response time. And so this really flattened that all out. Users quit complaining about it. Of course, not everybody was really happy with this. There were some users that wanted to submit thousands of jobs and have them all start at once. But we worked with them, and I'll show you a little bit of how we did that. The one thing I will note is that we put it on dev.shmem to minimize the amount of time that we spent reading and writing that file. And the thing that this kind of jogged in my mind was some discussion we had last year about hooks and about persistent data, because an awful lot of hooks need some sort of history. So looking at the data access methods for hooks, I kind of categorize them into three clumps. One is a configuration file. You basically read it once, or you write it once and then you read it a bunch of times. You've got some sort of quota data where maybe you refresh it once a day and then you come back and read it during the hook. And finally there's the kind of data file that we just saw where you're basically reading and writing it every time you initiate a job. And really I think one of the key things is all files associated with hooks are read many. Any data file you're going to have is going to get hit for every job initiation or every potential job initiation if you're rejecting a bunch of stuff. And the problem is there's no way to keep that data inside the PBS server. One, the hook's variable scope only lives for the life of the hook, and second, even if there was some way to put it in the PBS server, the Python engine itself resets every now and again for reasons I really should ask somebody sometime. But anyway, but I still think that there's some value here in Altair trying to address this, because this is a common need and something that is best addressed, maybe best addressed via an optimized solution from the vendor itself. And again, if you're only writing that file very infrequently, it probably doesn't matter where you put it too much. If you're rewriting it all the time, pick as fast a file system as you can get. And again, if there was a solution from Altair, I'd really love it. So my thinking on this is something like a PBS pickle or something like that has a well-supported and well-defined method of capturing data and passing it from one hook to its brother down the next iteration. So what can be done about small jobs? Well, Altair's already done a lot of stuff. Single threading of the server is still an issue, and I know that there are technical challenges and risks associated with trying to fix that, but from my point of view, QStat should never be blocking QSub. That's the reading and the writing. QStat should be kind of asynchronous. I don't know if this is still true, but at one time PBS did synchronous writes and forced flushing of the log files to make sure that nothing got lost, but that has caused us problems both on the head nodes, but especially on the compute nodes when moms really, when a compute node gets really heavily bogged down, we've seen issues where the mom would become unresponsive due to that. As I said, I'd really like to see an optimized mechanism for preserving data over from one hook to another. And finally, you know, just as a brainstorming thing, it seems like once you've put, particularly for a job array, once you put a sub-job on a node, you've already allocated the resources, you've already run your health checks, you've already done stuff. I think there's some value in looking at whether or not you can have kind of a lighter weight thing than a sub-job. So anyway, I thought I'd bring that up. From the sysadmin point of view, certainly you want to look at the performance and location of PBS home. We had it on a shared file system so that we could do PBS failover. That shared file system was not really the optimal place to put it, as it turns out. But that's something you need to watch out for as your transaction rates go up. And certainly, you know, it's our duty to make sure that we don't let one user cause problems for the rest of the user community. So again, we kind of did that. One solution we had here was using that hook. There are certainly other ones. And working with users to try and minimize the number, reduce the number of jobs, not necessarily, you know, just whenever possible. And then one thing definitely to watch out for is log file size, because as your number of jobs goes up, the log file goes up super linearly, the sched log in particular. And so, and then from a user point of view, I try not to ask much of my users. I try to let them submit what they want when they want, but they need to understand that, you know, all the overhead associated with the PBS job is not 100% free, and you know, what can we? If let us help us help them, sort of thing. So, I did want to note that in our environment, and again, this might be different at other sites, we use default exclusive for our nodes, because traditionally, again, we tended to have big jobs, and so sharing nodes was kind of the exception rather than the rule. But with this onslaught of new users and new applications, an awful lot of them are single core. And so we really need to work ourselves at trying to address this. And of course, the one thing you really need if you're going to share nodes is a decent memory estimate. And so providing tools so that users can tell us what that right number is kind of important. And this will only get worse as the nodes get fatter and get more cores. The need for sharing will increase. We use DynPBS. That's a locally written tool which dynamically adjusts the queue limits based on the current work mix. And that's actually really saving us a lot of grief in terms of day-to-day administration. Static limits are fine as long as your demand and load is static, but nobody's is. So this has actually come in really handy and has worked well for us. It helps alleviate the crush of a very large number of small jobs. One problem that this only arises for us once in a while is this small versus large job limits. So you really need to have your limit for nodes or for cores or however you're managing your limits based on the biggest job you're going to run, because otherwise that job will never run. However, you don't necessarily want to have that many nodes chewed up by an individual user. Now you can do user limits, user run job limits, you can do other things, but there's kind of this weird place where I really want to say this user can run 150 node job, or he can run 75 nodes worth of smaller jobs. And again, it doesn't rear its head all the time, but it does pop up, and again, the increased job count is going tends to make this a little worse. I guess one of my questions is there room in PBS Sched for a rate limiter? Is this something that other folks would use if it was available? If it was, talk to Bill, right? That's. But again, we have our hook. We're happy with it. It wasn't that terribly hard to write, although I don't seem to be getting any better at writing hooks than I was a year ago. I still put as many bugs in as I ever did. But you know, if it's of general use, if other people have seen this issue of just an onslaught of jobs causing disruption, it's certainly worth talking about. And then what I'll call hybrid job array strategies, and that's the idea that instead of doing a job array to 1 million, you basically roll it up into a bunch of groups of cases that you run serially. So that's kind of, I've got a kind of simple example here where instead of doing 5,000 job array subjobs, we're doing 50 subjobs, each handling 100 cases. It's relatively easy if you've already got a job array job to convert this, to add one more local index, and then use the step function here to say how big a stride you want between the various subjobs. So, just a couple things on performance monitoring and measuring and tracking. More jobs, more data. Here you see just this kind of telltale, somebody submitting job arrays, and as we work them down. One of the things, this is always tends to highlight the fact that things like average wait time and things like that can kind of fool you, because you might look at these jobs and think, oh, well, they're trivial jobs and they waited a long time and we're doing something wrong, when in fact there's really nothing we can do when they blast us with a bunch of stuff all at once. This chart I've shown before. It's kind of my attempt to get a bird's eye view of all the jobs running on the system over time. Red is wait, green is run. These charts are still useful, but I'll just say I'm starting to run out of pixels as we get job counts that are too high. This was a really good chart on a Cray X1. It's not working so good for our clusters. So just to sum up, and I hope I'm kind of scary. Just to sum up, you know, I think there's some broad trends, and again, this doesn't apply to every site, but broad trends that there's more jobs coming from more users to HPC, and so and again, we're moving toward a general engineering cloud. This stuff that puts a lot of pressure on PBS and associated stuff on the head node storage and compute. For us, implementing a job array throttle really did help alleviate some of the pain associated with this. You know, I do believe that, you know, every time you write a hook, you almost have to read some data somewhere, and in a lot of cases, the data you want to read was read or written by another hook. I think there's some value in trying to come up with some way of standardly sharing data between hook iterations. And guess what? We all got to work together as a team to solve this challenging problem. So I guess I'll just say deal with it. And that's what I've got. So, yes, Steve?
I guess my question is how much of the trouble you were having with these spikes was due to running out of privilege flow?
Running out of?
Because that's what I would expect to see happen first. And that would also affect whether you could QDEL, because the VMs use privilege ports to authenticate the server. And if you're out of privilege ports, you really can't do much of anything.
Okay. Well, at the
in which case, we're going to make it better.
Okay. Okay, well, I guess I'll comment that at the time that we were seeing that problem, we weren't necessarily aware that privilege ports was a concern. So, you know, I fix first and ask questions later, I guess, is kind of my strategy on it. But
so basically, you've got 512 that you can use, and the kernel will hold them for a minute after you let go of them. like that really easy to run out.
So my denial of service is actually a lot more,
It's
not lot less theoretical than one might think. Okay.
It's okay.
Thanks.
Time for at least one more question.
Sure.
Thank you.
Hi, Greg.
So I'm kind of curious about this trend towards large number of smaller jobs, and I would have thought maybe the opposite, that since the desktops are becoming more powerful, a lot of those jobs would tend to stay there. Is there some other, is it just that you have a lot more users, or is there some other factors that are driving up the number of smaller jobs?
Well, sometimes it's kind of hard to tell. I think that a lot of it has to do with filling out matrices, like we need to do an analysis on all these angles of attack in this flap position and something else. And each one of those might be doable as a single case on a desktop, but it would tie the guy's desktop up for, you know, an hour or a day or something. And so, you know, they suddenly realize, hey, there's this resource available, and there they are.
Well,
so
perhaps more ensemble analysis and design of experiments kind of stuff.
Yes, definitely that is a big factor. But I think the other thing that we've seen is even for folks that just are doing single analysis, they'll find that yes, they could run Nastran on their desktop, but then they can't do it. Then they can't read their mail anymore, and that's enough to get them to look. And that's step one. And then step two is, oh, by the way, if I'm running, I ran that one case and it came back in an hour, I could probably run, you know, 20, 50, 100 more. So that's not to say that we don't still have our traditional folks doing overflow and CFD++ and large arrow stuff. We still do that, but in the structures world, we tend to see smaller jobs, and we tend to see a lot more of them. Plus, we just see other stuff that I don't even necessarily know how to characterize. You know, we try to keep up with our users, but they're coming at us faster than we can keep up. So.
There are more coming.
Yeah, I was afraid that might be the case.
I have a quick question regarding, you said you had an issue with the Prologue and Epilogue. How big are they? What was the issue that it's running slow?
The key problem with our Prologue and Epilogue are written in Perl, and they were written by me umpteen years ago. And one of the problems that we have is that they run serially across each node associated with the job. And again, we wrote them, back when we wrote them, we didn't really write them for performance as much as safety. And so we weren't, again, with a much lower frequency of jobs, we didn't really feel like we had to optimize them that much. If they took a second or two, that was no big deal because they were going to run for 6 or 8 hours and it didn't matter. But now that the turnover has gotten much greater, we just need to take another look. And again, we've taken a look at, you know, I attended the presentation for the training for mom hooks on Monday, and I was like, yeah, there's some benefits there. One is PBS will spawn processes across all the nodes simultaneously, so that will help us a lot for doing the kind of stuff that we do on nodes, which is mostly just cleaning up processes and cleaning up scratch directories. But still, it takes more time than we think we can afford.
Thanks. There was time for one more.
Well, it's just a comment on the previous one about single node or single core jobs. We actually see that usage pattern very commonly at commercial sites. Huge numbers of single core jobs in certain use cases. Surprised us a bit too, but common.
Okay. Thanks. Well, again, I'd really, you know, I'm here to learn, and I know that there are folks here that have been dealing with large quantities of jobs for a long time under PBS. So I'd appreciate, you know, you grabbing me after the session or chatting anytime during the conference. And thanks again for your time.
Thank you very much.